Some of the graphs have a positive slope, others have a negative slope. Some are in quadrant 1 only, some in quadrant 2 only, and some are in both. Okay, and then things like negative and positive slopes. They're all linear graph, lines going up or down, consistently linear graphs. Bye. Straight lines going up or down. Okay, cool. So these buggies, the claim that we were investigating was that they all traveled at constant speed. Was there evidence to support that in the data collection? Yeah, what do you think?
So the points were pretty close together.
Okay, points were pretty close together. And what else did you notice about the points? Like when you say close together, can you say more about that? What do you mean?
Yeah, so I mean, like, if you draw a line of the east bit, then those two points are either on the line or really close.
Okay. And like if we look at the tape marks on the floor, do we see evidence here that the speed was pretty constant? Right? Okay. So they're pretty evenly spaced. And so then based on what we're seeing from the graphs, like if you look at the tape marks, you can tell the speed's pretty constant because the dots are evenly spaced. If you look at a graph, you can tell the speed's pretty constant because what's true of the graphs?
They're linear, so it goes up by the same amount that it goes out every time.
Okay, there you go. So there's a really nice repeat pattern in terms of the change in vertical, the change in the horizontal. If the graphs are linear, that's to tell that the speed is pretty constant. Okay? So we picked up on that. People mentioned positive slopes versus negative slopes. So if I group these like that, there, there, there. Oh man. So many boards. Alright? So if I group them that way by positive slope or negative slope, run that by your neighbor. What's kind of ignore the stupid prompts. I just want to give you a fresh prompt. What's the this or the that? Groups that did this end up over here. Groups that did that end up over here. Like, run that into the pair deck quick. That a group gets a positive slope or a negative slope is an indication of what? So positive or negative slope on a position versus time graph, that's telling us what in the pair deck? All right. We got some differing opinions here. Wow, what is going on with this today? Gotta get my scale sorted out. Okay, so here we're talking about positive versus negative slope. And some folks saying that has to do with where the group started. Okay, indication we all started from different places. Other people are saying it has to do with the direction the buggy travels. So can you run that by your neighbor really quick? Is the positive or negative slope telling you about where you started or direction of motion? And if it's not telling you the other one, what tells you about the other one? Right, so that's what I'm asking. Oh, is that a real thing?
What?
That's not like somebody's fake
Are you sure?
spider? Crazy.
It looks pretty weird.
Looks-
Oh, that was fake. Though.
That one looks deadly.
Bro.
I'm not messing with that. Go for it. All right. So bold claim is that positive or negative slope represents starting position. Agree or disagree on the pair deck? So the way this works, drag your dot. Positive or negative slope represents starting position. We got one person that agrees with that, but a whole lot of people that don't. Okay? So let's pair deck out loud quick. Most of us are seeming to say that that does not represent starting position. If that does not represent starting position, what does represent starting position? Pat? Well, that's what we're saying here. Are you saying the slope represents? Okay. What represents the starting position? I guess I'm asking. Ian?
The vertical. Intersect.
Vertical intercept. Okay, and that's what we're talking about up in the corner. Here, the vertical and then intercept at 90 centimeters represents the starting position of the car relative to the measuring angle. Okay, starting position. So, starting position, that relates to vertical intercept. This group started at 0, this group started at 30, that group started at negative 0.8. So this is very minimalist, which I don't mind, right? Did anybody try to like put all the numbers on here? Yeah, kinda. Okay. Yo, Ian, what's that number?
One number.
The one between my hands.
10.
See? Okay. Too small, can't read it, don't bother with it, okay? Hey Ian, what's that number?
13.
Yep. Okay, good. So you can see some of them. So yeah, don't write really small stuff. The stuff that you do write it big. And really the only thing I care about is the vertical intercept here is negative 80. Okay? Ian, what's that number?
-8.
Boom, okay? So don't worry about all the other stuff. Maybe throw 0 on there for relative kicks and giggles. But that's where we started. So vertical intercept represents where we started. The suggestion then would be that the slope has to do with the direction of travel. These were all moving towards City High. These were all moving towards the landfill. Okay? So we can tell direction of travel. Positive or negative slope on a position versus time graph indicates direction of motion, or whatever you want to say. Direction of motion. All right, cool. So then, if you take a look at the number values for these things, this group's got negative 33.3 centimeters for their slope. This group's got negative 0.169 no units. This group's got negative 18.75 no units. Here we have 35.3 centimeters per second. We have negative 12.05 no units. Negative 215 meters per second. Negative 12.5 centimeters per second. This one's a classic, 20 thirds, no units. 33 centimeters. 46 millimeters per second. 0.46 meters per second. 23.5 centimeters per second. 7.4 centimeters per second. Okay. So what is the smallest then? I think 46 millimeters. 7.4. Let's see. So it's a little challenging because we did different units of measure, some centimeters, some meters. 215. So I'm not really good with fractions. What is 1/7.5? What is that roughly? Hell if I know. All right. 20 thirds. I can kind of do that. That's 7-ish. So let's see. Oh, but I don't know what the unit. Oh yeah, it says centimeters per second. Okay. So I think this is the smallest one, and it's this one, and that's this one, this one, this one. Ooh, shoot, nope. So right now I'm rank ordering these based on the slope value. Absolute value of the slope, I should say. We'll let it slide. Alright. So right now I've got them ranked on absolute value of the slope. So make sense out of that. What is that telling you? And what do you notice about the boards? Okay, give me 1 second. Let me. So they're rank ordered on slope. Absolute value. What do you notice here, friends? All right, you're picking up what I'm putting down.
No, I mean, Mark knows about it.
So, friends notice things like blue cars tend to have higher slopes than red cars. Where am I trying to go with this? There we go. Lots of red on the left, blue on the right. Large slope means the car went faster. A lot of speed variation in between buggies. In general, blue car graphs had a larger slope than red car graphs. Blue cars are faster than red cars based on the absolute values of speed, slope calculations. Okay, so key stuff here, and then I have some more things. We have a friend here that made up a word, okay? And they say that that word represents the slope on the graph. So let's see. You cool with this? Thumbs up, thumbs down. If we want to call the slope on a position time graph velocity. You cool with that? Somebody's proposing a term, velocity, and they want to define that as the slope on a position time graph. You cool with it? Polls are closing. All right. Votes are in, and we're agreeing with that. So, velocity, when we talk about velocity in here, we mean the slope on a position versus time graph. I need an is right there. Velocity is the slope on a position versus time graph. Tells us how fast, but as we mentioned earlier, it also tells us what direction. So that's important. Let's the suggestion here is that if we had a race between a red buggy and a blue buggy, that wouldn't be a very fair race. Let's check it out. Okay. So that would seem to be supported. Blue buggies are slower than red buggies. Why, you ask? Well, if we open one of these suckers up, they're powered by two, I think, C-cell batteries.
Disembowelment.
Pretty much. We're going to read the entrails here. So in the red buggy, you got a C-cell battery. Oh boy. And I got another C-cell battery, but if you look there, I MacGyvered a little thing with some, I guess it's like a manila holder or something like that. Okay, it's a little jumper that goes around the battery. Battery is basically just a spacer. So this red buggy is only powered by one battery. I put that up on Twitter the other day, and I got some props from the science advisor on the MacGyver show. So I'm feeling pretty good about that too. That's all right. But that's how we managed to get different levels of velocity. So this is kind of an understanding too, like with labs in general. I don't like to do labs like a paragraph lab where we all get the same result. Like the only way the result was different is if you did inches and centimeters, right? I guess I could have made you do different other units of measure or something like that. But otherwise with labs, this is how I make it interesting to talk about later. Like I make sure that the cars have different speeds, or they can have different starting positions. We already talked about how that makes the graph different, or they can travel in different directions. We want that. We want differences in the graphs because that helps us figure things out. Like, oh, positive or negative slope indicates direction of travel. Cool, cool. All right. What about screwdriver? That's weird. Vertical intercept, we already talked about that. Significant because it's the starting position relative to the number line. I think they probably agree. Initial position, starting point. Car started at time 0 at position 11 centimeters. Vertical intercept represents starting position. Okay, so that's what I'm talking about when I say like the meaning of the vertical intercept. The meaning of it here is where you started. Right? So we got that bit figured out, and then we can take a gander down here at the equations. 5 out of 10. 5 out of 10. Five out of 10. 10 out of 10. 5 out of 10. 5 out of 10. 5 out of 10. 5 out of 10. 10 out of 10. 5 out of 10. 5 out of 10. So focus on the 10 out of 10s here. What do they have in common? I mean, they're 10 out of 10, but there's issues here, okay? You don't need to include units with variables. The units for the variables are implied by the unit for the slope. And this is in centimeters per second, implies that position is in centimeters and time is in seconds. So don't include that. It's just extra stuff. It's not wrong. It's just not right. Okay. So something like that. Proper units on any numbers in the equation. So this number, centimeters per second. This number, centimeters. Times time. Okay. Not times seconds. I had a friend that wrote that somewhere. I feel like. I don't see it now. But if you write like seconds for the variable, some donkey's going to see 12.5 centimeters per second times seconds, and they're going to go, oh, okay, cool. Seconds cancels out. 12.5. No. So that's why you write the variable. So distinguish variable from unit. Units go on numbers. Don't put units on variables in the equation. All right. So you don't need to correct your whiteboard, but do correct your sheet of paper, okay, before you get ready to hand that in. Make sure that looks cool. I'm going to get a picture of those two whiteboards as far as what 10 out of 10 looks like. Well done, Alex and Steve. 5. What's that? What up? Was it good? Why did I put you on the ground? What did you do? What did you? Oh, okay. What's your fraction?
Yeah, I'm gonna write it down. Units finding that paper.
Units on numbers. So what is the unit
So what
associated
is
with
the wrong anyway?
Hey, and also, square fractions. It's not a math class. Fractions are exact. 1/2 has precision for days. We usually only know things in 2 or 3 digits, so don't express things in fractional form in here. All right? It'll mess with my head. Also, especially, nobody did this hour, but like last hour, I had like this for an answer. Like, it's more exact. Well, cool, but like, what even is that? This is fraximal. No fractionals, okay? Decimal form, 2 or 3 digits. I crap you negative. The AP exam, it says something along the lines of like report answers to 2 or 3 digits. They don't track sig figs. You won't lose points if we're supposed to have 2 sig figs and you put 3. But if you put calculator diarrhea, if you go in that room and you smear calculator diarrhea all over that exam, you throw something down to 13 digits, they're gonna take points off.
Does that happen like in past years?
Somebody wipes their hind end on
sure
the
it's
test.
happened. I'm sure it's happened.
Trust me, I am of these people. I'm not a reader myself, but I know the readers, and you will offend them with calculator diarrhea. They'll just be like, this kid didn't pay attention in class. All right, so make those corrections on your thing. Put your thing in the thing. Make sure you got your name on it. Okay?
People need to submit.
Yeah, unless I will. Hey, gang. Very rarely is a lab a group lab. I will explicitly state it in class that it's a group lab. Those tend to happen. Even the one that's coming up is not a group lab. It's going to be individual submission. I try to weave some interdependence into it. Like here, theoretically, each of you are doing different trials of data, right? So I'm interested in seeing that. Okay? So make sure you got your name on there. Get it in the things. I mean, if you want me to split points between the two of you, I will. Go ahead and clean up these whiteboards. Put them back to the clean whiteboard storage. Maybe. It might be out. I might have to print some. Yeah, I'll print some. I'll be back. What up, Ian? Right back. Oh. Basket. All right, 19. We're out at 22. That's not too bad.
We need to label y except all this doesn't work.
That looks good, I think. Yeah, I think I like that.
You don't. So even for seconds, you don't need like a relative.
I don't need like the scale. I just need.
Okay.
Yeah, I mean maybe if you put like the max value, that's helpful.
Yeah. Okay. Yeah.
If you want to say what.
That's what I was
maximum
thinking. Yeah. So you can like relatively,
I can quickly look at your graph and be like, oh, this kid did something wrong.
Why do you have Sour Patch Kids?
Oh, because in my English language learners class, we're talking about senses. And so like
they get
taste. Yeah, they got Takis, they got Sour Patch Kids, they got pretzels, marshmallows, all the goodies. All right, I was just gonna do something. Now I don't know what it was. Oh, it was that. Word. Come on, man. Where's the thing? More documents. What's up, buddy? Uh-oh. You get it to me tomorrow? That'll work. Ooh, you know what? I'm gonna fix this. Hey, how do I rotate text in Word? I want to rotate the text. That's got to be a thing.
Oh, you can, yeah.
Can I just like twist it? Yeah, it's not. There's gotta be a text
You can insert a text box.
box. Tools, text box tools. Text direction. Text direction. Oh!